Okay, so before we move on to area between curves, I wanted to do one problem that was exclusively arc length, and I'm just going to look at an application. So we're looking at a graph here that's supposed to represent the path that a roller coaster actually follows, and we've got units measured in feet on both axes. So we start from a height of 250 feet, we drop down to ground level, we come back up to roughly 150 feet, and then we drop back down again. So we want to find the length of this curve, and we have an arc length formula. I've boxed that one, but actually I would say this is the one I would memorize. Not that it makes a huge difference. So we just need to know how to use this formula. Oops, A to B. So just get it memorized and then plug and chug. So if I want to find dy dx, I did give you pretty messy numbers here, but we should be able to handle that, I hope. The 240 is just going to drop out. We'll get a negative 1.68 just as a constant, and then we'll get negative 36 times 2, 72,0072x. And then we will get, mine's not writing small enough, this isn't going to fit. Drop down the 3. Oh, goodness. 42 times 3 is 126. I'm cheating so that you don't have to wait for me to do this in my head. So we had 4 zeros, now we'll only have 3. 2, 6. Oh no. Okay, there we go. 126x squared. And then 6 times 4 is 24. We had 1, 2, 3, 4, 5, 6, 7 zeros. So now we're only going to have 6. So it's going to be minus 1, 2, 3, 4, 5, 6. And then a 2, 4. And an x cubed. So this is my derivative. Right now I'm sort of kicking myself for making this one so long to write down. Here, let's zoom in here. So if we actually want to calculate the arc length, we're going to take the integral from 0 to 500 of the square root of 1 plus this whole mess, 0. 126 x squared. Oh, I'm still not quite going to fit it. Minus 1, 2, 3, 4, 5, 6, 2, 4 x cubed. And then the square root would capture all of that. And there would be a dx out here at the end. Pretend like that didn't look terrible. And it fit all in one line. And then this in general is going to become a calculator problem. There are a few functions that works out nicely. Any linear function, which is not that helpful because you could probably figure those out without an integral, but the integral will be really nice if you're trying to do a linear function. There's some trig function setups that work out nicely because you end up with something that a Pythagorean identity can simplify. For the most part, these integrals are terrible, and we don't end up with something that we know how to integrate. So this one, when I plug it into a calculator, I don't know if I remember, 765.8. 765.8 feet is the length of the ride. So there's an application of the arc length formula. So again, not hard to use. You just need to make sure you've memorized the formula, and then it generally becomes a calculator problem. So on a no calculator test, I would either give you something that's going to work out nicely, or I would just ask you to set up the arc length calculation for me and not actually do it. All right, thanks for watching.